Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome you all the students of class 11 for our chemistry lecture. As you know, we have started chapter elements of group 1 and 2. This is our sixth lecture for the same. So your student, in our previous lecture we have completed chemical reaction of elements of group 1 and 2. Inshallah, today we are going to study diagonal relationship. Now, here your group 1 element is your alkali metal and group 2 element is your alkaline earth metal. So, it is expected that elements belonging to the same group exhibit similarity and gradation in their property. Here, the elements which is belonging to the group 1 will be having the same or little bit gradation in their property. The first alkali metal is your lithium and the first alkaline earth metal is your beryllium. These two elements, that is your first alkali metal lithium and the first alkaline earth metal beryllium, do not fulfill this expectation. Which expectation? That they should exhibit similarity and gradation in the properties with respect to their group. Hence, lithium shows many differences when compared with the remaining alkali metal. As lithium is belonging to the group 1, which is alkali metal, it shows differences and resemble with magnesium. Where is magnesium? It is the second alkaline earth metal. Similarly, likewise, beryllium shows many differences with remaining alkaline earth metal. Group 2, that is your alkaline earth metal. Here the first element beryllium, it shows many differences with remaining alkaline earth metal and shows similarity with aluminium, which is the second element of the next main group, that is your group 13. So the relative placement of these elements with similarity properties in the periodic table appears to be across a diagonal. Here diagonal means cross and is called diagonal relationship. We have studied table 8.6 in our previous lecture. So your student, diagonal relationship between lithium, which is group 1 element and belong to second period, it has a diagonal relationship with magnesium, belongs to second group and third period. Here you see a cross line between lithium and magnesium, sliding line, okay, slanting line, lithium and magnesium. So it shows a diagonal relationship between lithium and magnesium. Similarly, beryllium belongs to group second. It shows a diagonal relationship between group 13 element belonging to third period, that is your aluminium. So lithium shows diagonal relationship with magnesium while beryllium shows diagonal relationship with aluminium. Here you see resemble between lithium and magnesium. The elements lithium, when it is reacted with air, here you see the first column, product of reaction with air. When this metal reacted with air, okay, it get converted into lithium oxide. Okay, when it is reacted with nitrogen, it get converted into lithium nitride. Similarly, when magnesium is reacted with oxygen, it get converted into magnesium oxide, while with nitrogen it get converted into nitride. Leaving behind lithium, group 1 element, but it is reacted with oxygen, it get converted into metal oxide. Here metal dioxide. Okay. So here student, lithium shows diagonal relationship between magnesium. We are supposed to take a pen and book and write down the reaction. Lithium, when it is being reacted in the presence of air, it gets converted into lithium oxide and lithium nitride. The second reaction, product of thermal decomposition of carbonate. When your metal carbonate, okay, when it is being reacted, it is being heated, it get converted into Li2O plus CO2. Okay, Li2O, it means when the reaction is in this sense, Li2CO3, lithium carbonate, when it is being heated, it get converted into Li2O, lithium oxide plus carbon dioxide. Okay, then when magnesium, it is being heated, the magnesium carbonate, when it is being heated, it get converted into MgO, magnesium oxide plus carbon dioxide, while the other elements of group 1 shows no reaction. Okay, while group 2, it shows magnesium oxide plus carbon dioxide, your metal, whatever your metal, when it is being heated, metal carbonate, when it is being heated, get converted into metal oxide plus carbon dioxide. What is the properties of chloride? It is dissonance for lithium. Similar it is for magnesium. While for group 1 there is not diluent, while group 2 it is dilutions. Okay. Formula of crystalline chloride. What is the formula for crystalline chloride? For lithium, it is lithium chloride into 2H2O, it which is resemble with magnesium, whose formula is magnesium chloride into 8H2O. While for the other elements of group 1, it is only metal chloride. Okay, you take sodium, it is sodium chloride, and so on. While the other elements of group 2, it shows metal chloride into H2O. So here with these reaction you see the resemblance between lithium and magnesium. Now here table 8.8, it shows resemblance between beryllium and aluminium. Here your element beryllium. What is the nature of bonding? Here chain structure with chlorine bridges. Whenever you see the beryllium is being connected with chloride in the form of chain structure. Okay, beryllium chloride is a strong Lewis acid. You know what is Lewis acid? You have been studied in your 10th standard. So beryllium chloride is strong acid and it is soluble in organic solvent. Okay, when we are adding beryllium in organic solvent, it is soluble. What is the properties of it oxide? Its properties is amphoteric in nature. It is neither acidic, it is neither basic, it is amphoteric in nature. While aluminium, similarly with aluminium, as we know, beryllium shows diagonal relationship with aluminium. Okay, while lithium shows diagonal relationship with magnesium. They resembles in their properties. So here when aluminium it is linked with chloride, it form dimerge with chlorine bridges. Here you see beryllium is strong Lewis acid when beryllium chloride. Aluminium chloride is also strong Lewis acid. While you see beryllium is soluble in organic solvent. Similarly, aluminium is also being soluble in organic solvent. This is the oxide of beryllium is amphoteric in nature. Here also aluminium oxide is amphoteric in nature. It is neither acidic nor basic. It is amphoteric in nature. While the other elements of group 2, they are ionic. They form ionic bond. while group 13 element they form covalent bond. Here the other elements of group 2, they are not Lewis acid, while your beryllium and aluminium, they are Lewis acid. Similarly, group 13 is also Lewis acid. Your group 2 leaving behind beryllium, all the other elements are insoluble in organic solvent, while your group 13 elements, they are soluble in organic solvent. So here student, these elements shows resemble which elements? Beryllium element shows resemble with aluminium. Aluminium which belongs to group 13. Okay. Yes, much of the properties of group 13 is similar to beryllium. Now group 2 element, when it is in oxide in form, it shows basic in nature. It is basic in nature, while group 13 element is similar to the properties of beryllium and aluminium, which shows amphoteric in nature. So these are the few characteristics of the elements of beryllium which shows diagonal relationship with aluminium. So here student, the diagonal relationship between the elemental pairs belonging to different groups and period is due to the similarity in some of their atomic properties. Fine. What is the reason behind it? The reason behind it is their similarity in some of their atomic properties. Thus, atomic and ionic radii of lithium and magnesium are very similar. The atomic and ionic radii of lithium and magnesium is similar. Similarly, in the case of beryllium and aluminium, the charge to radius ratio of their ions is very similar. So here student, the diagonal relationship between lithium and magnesium is due to their similarity in their atomic and ionic radii, while the diagonal relationship between beryllium and aluminium is due to their charge to radius ratio of their ions. Okay, so here student, you are supposed to study some of the resemblance between lithium and magnesium and some of the reaction of resemblance between beryllium and aluminium. You are supposed to take a pen, copy and write down the reaction. Hope you all have understood. If not, inshallah we will meet, and then whatever the difficulty you face, we will sort it out. Hope you all have understood. Till then, take care, study well, do your best. Thank you, student.